All right, in this video, we're going to work a bunch of example problems related to arithmetic sequences. These are different kinds of examples, a bunch of different kinds of examples. So by the end of this video, you should have a really firm grasp, a comfortable understanding of how to work with arithmetic sequences. Okay, first problem, determine whether the sequence is arithmetic. If so, find the common difference. Okay, so we determine if a sequence is arithmetic. If we're given a sequence and we want to know if it's arithmetic, again, every term should be like you're adding the same, or you're adding or subtracting the same amount. So from 2 to 4, 4 minus 2, we add 2. So for this to be arithmetic, we should be adding 2 to 4. But we're not. We're adding 4 to get 8. And then here we're adding 8 to get 16. So it's not the same difference. So this is not arithmetic. Okay, same problem. Determine whether the sequence is arithmetic. If so, find the common difference. So we just subtract for term 1 and term 2, subtract term 2 from term 1 to see what the difference is between the two. So we've got 14 thirds minus 4, which is 14 thirds minus, so turning 4 into a fraction, 4 times 3 is 12. Okay, so this gives us 2/3. So here we add 2/3. So now going from 14 thirds to 16 thirds, we subtract 16 thirds minus 14 thirds. We added 2/3. Okay, now going from 16 thirds to 6, what did we do? So 6 minus 16 thirds. So let's turn 6 into a fraction. 6 times 3 is 18. So 2/3. We added 2/3. So yes, each time in this sequence you're adding 2/3. So this is arithmetic, with D is equal to positive 2/3. All right. So first, write the first 5 terms of the arithmetic sequence with the given first term and common difference here, and then write a recursive formula to define the sequence. So again, this is an arithmetic sequence, which we know is each term has a common difference, or it could be a difference or a common. You're either adding or subtracting this constant to each term. If it's positive, we're adding. If it was negative, we would just subtract. So write the first 5 terms of the arithmetic sequence. So we start at 6. Okay, so that's the first term, right? Now to get the second term, you just add 5. To get the third term, just add 5. Fourth term, add 5. Fifth term, add 5. Okay, so that's part A. Now recursive formula. Remember, a recursive formula is you just write like you're writing a sub n, a formula for a sub n, but instead of just in terms of like n, you're writing it in terms of previous terms. Like this could be like a10, but it's going to be a function of a9, let's say, like of the term before an. And the reason for a recursive formula is because it might be a certain sequence might be a lot clearer or a lot more presentable or a lot more easier to analyze if you write it recursively. It might or it might not be. So let's see if an arithmetic sequence is like that. And yeah, an arithmetic sequence is represented very cleanly with a recursive formula, because you just, what are you saying? You're saying you have the previous term, right, plus D. That's it. Very simple. So you could argue that you want to present an arithmetic sequence recursively, because look how clean it is. It's easier to understand this way. But you also need to, you can see that you need to, when you write a recursive formula, you need to specify what the first term is, because otherwise, if I just give you this formula without the first term, then I don't know where to start. Like I can't give you, if you're just given this formula without a sub 1, I can't give you any term. because I don't know where we're starting. So like without a sub 1 is equal to 6, a sub 3 is what? I have no idea. Well, are we starting at 100? Are we starting at negative 500? I have no idea. So you have to specify a first term. Okay, write a non-recursive formula this time for the nth term of the arithmetic sequence based on the given information. And then find the indicated term. Okay, so a non-recursive formula. So once you've done this enough times, you kind of have the formula for the non-recursive formula for an arithmetic sequence memorized. But you can reason through. If you don't have it memorized, you can just reason through how to make this formula. So non-recursive formula, you're going to have the nth term of the sequence, but as a function of just n, not of any previous term. So, okay, so let's say a sub n, we start at a1, okay? Now what? So you're starting at a1, that's good. That's a start. But now you want to add, for each successive term, you want to add d to it, right? But assuming we're going to assume we're starting at n is equal to 1. You don't have to start at n is equal to 1, but let's just assume we're starting at n is equal to 1. We want to make sure that for a sub 1, we get a1. So we'll put n minus 1, right? And then times that common difference. Because at a sub 1, this 1 minus 1 is 0. This whole term goes to 0, and you have a1. That's what we're looking for, right? But then at a2, we want to add d to a1. So 2 minus 1 is 1 times d, so a1 plus d. There you go. Now, a3, we want to add 2 times d to a1, right? Because you're adding d twice. It's 2 ahead of a1. So a sub 3 is 3 minus 1, so 2. So there you go, right? So now, well, let's plug in our a1 and our d. So we haven't completed the formula yet. So a1 is 7 plus n minus 1 times 10, and we can simplify this. So plus 10n minus 10. So a sub n is equal to 10n minus 3, right? So a sub 1, 10 minus 3 is 7. A sub 2, 10 times 2 is 20, minus 3 is 17. And that's right, you added 10 to 7. So it goes 7, 17. The next one should be 27, right? So 10 times 3 is 30, minus 3 is 27. So that's right. So that's our a sub n. Now find a sub 22. So we just plug in 22. Minus 3. So 2, 17. That's a sub 22. Okay, same problem, just as before. So first, let's find the a sub n. So a sub n is a sub 1. Okay. 1/2 plus n minus 1 times 1/3. 1/2 plus 1/3 n minus 1/3. Okay, so 1/2 minus 1/3 is going to be a negative number. So we have 1/3 n plus, so this would be 1/2 would be 3/6 minus 2/6. Oh, this could be a positive number. 1/2 minus 1/3 is positive. So we get a sub n is equal to 1/3 n plus 1/6. Okay, so that's a sub n. Now let's find a sub 10. So 1/3 times 10 plus 1/6. 10 plus, okay, so 3, so multiply 10 thirds times 2 over 2, you get 26 plus 1/6, 21/6, which you can divide the top by 3, divide the bottom by 3, 7/2. Okay, Jim has 8 unread emails in his inbox before going on vacation. While on vacation, Jim does not read email. If he receives an average of 22 emails each day, write the nth term of a sequence to find the number of unread emails in his inbox at the end of day n of his vacation. Okay, so before he goes on vacation, he has 8 unread emails, and we're trying to define a sequence that represents the number of unread emails in his inbox at the end of each day of end of his vacation. So when he starts his vacation, like before going on vacation, when he starts the vacation, A1 is equal to 8, right? I'm assuming this is going to be an arithmetic sequence. It doesn't tell us that, but let's just see if we can reason just from the problem if it's going to be arithmetic. So while on vacation, Jim does not read email if he receives an average of 22 emails each day. So yeah, it's going to be arithmetic because each day you add 22 unread emails to, like, every single day it's an additional 22 unread emails to the inbox. So that's like an arithmetic sequence with D is equal to 22, you see? So now we have, it's just like one of the previous problems we did. It's just a word problem. If we want to write A sub n for the number of unread emails in his inbox at the end of each day. Well, wait, okay, we got to be careful here. So this might, okay, so yeah, see, these word problems can be tricky. You have to really read it carefully. The nth term of the sequence defines the number of unread emails in his inbox at the end of day n of his vacation. Okay, we know D is 22, but I messed this up here. So this is not 8 because he starts his vacation, right? But like, so A sub 1, it's at the end of the first day. How many unread emails are in his inbox? Well, before he went on vacation, right before he went on vacation, he had 8. So, but A sub 1 is not 8 because it's not the end of the first day yet. That's not what that's not what the question's asking, right? 8 plus 22. So A sub 1 is going to be 30 because at the end of the first day, he has 8 plus 22 unread emails. And then it's asking, so write the A sub n for the number of unread emails at the end of each day. So after the second day, it'll be 30 plus 22. After the third day, it'll be 30 plus 22 plus 22 because you had 2 days passed. So now it's just like one of the previous problems. Let's just write, if we want to write a formula for the number of unread emails at the end of each day, this is just this is a sequence, right? You start off at the end of the first day, it's 30. At the end of the second day, it's 30 plus 22. At the end of the third day, it's 52 plus 22. Right? This is just a sequence. So, like we did in the previous problems, A sub n is A1 plus n minus 1 times D. So this is 30 plus n minus 1 times 22. 30 plus 22n minus 22. So this is 22n plus 8. And that's your answer. Okay, a new drug and alcohol rehabilitation program performs outreach for members of the community. The number of participants for a 4-week period is given in the table. Okay, so after So in week 1, 34 participated. In week 2, 50 participated. In week 3, 66 participated. Week 4, 82 participated. Okay, it's just asking, based on this data given, does the number of participants follow an arithmetic progression? Okay, so yeah, is each week the number of participants increasing by the same difference? So 50 minus 34 is equal to 16, okay? 66 minus 50 is 16, and then 82 minus 66 is 16. So yes, it is arithmetic progression. Write an expression for the nth term of the sequence representing the number of participants where n represents the weak number. Okay, so again, arithmetic, a formula for an arithmetic progression. We know that our D is positive 16, and then our A1 is 34. So for an arithmetic sequence, we know that A sub n is A1 plus. Okay, so 34 plus times 16. So 34 plus 16 and minus 16. So A sub n is equal to 16n plus 34 minus 16 is 18. Okay, so that is your formula. Okay, if this trend continues, find the number of participants in week 10. So they're just saying, what is A sub 10? So just plug in n is equal to 10 into the formula we just made. So 160 plus 18, 178. Okay, find the number of terms in the finite arithmetic sequence. Okay, so this goes from 8 to 320. And it's telling us that it is a arithmetic sequence. So there should be a common difference here. So 8, go from 8 to 14. So what's 14 minus 8? Plus 6. So this should be plus 6. Yes. This should be plus 6. Yes. Okay, so for this arithmetic sequence, we have A1 is equal, we start at 8, and D is equal to positive 6. All right, so let's write the formula for this. A sub n is equal to A1 plus n minus 1 times D. So 8 plus n minus 1 times 6. So we've got our A sub n is equal to 6n plus 2. Okay? And this goes from n is equal to 1 to, and we're trying to find this term. This is what we're trying to figure out. So how can we figure that out? Well, we know, we just say, okay, when A sub n is equal to 320, what is n equal to 2? Right? So just plug in 320 and solve for n, and that would be the number of this term. 6n plus 2. 6n is equal to 318. So n is equal to 318 divided by 6. So 53. There are 53 terms in this sequence. Okay, same problem. They're saying this is an arithmetic sequence, so there should be a common difference. So we go from 11 to 10.7. So we're subtracting 0.3. So the D is going to be negative this time. Okay, so we should be subtracting 0.3 again. Yes. We should be subtracting 0.3 again. Yes. Okay, so our A1 is equal to 11, and our D is equal to negative 0.3. A sub n, A sub 1 plus n minus 1 times D is equal to 11 plus n minus 1 times 0.3 plus 0.3 n minus 0.3. So A sub n is equal to 11 minus 0.3. So we got 0.3 n plus 11 minus 0.3, 10.7. Okay. So now to find the number of terms in the sequence, we just plug in the last term. So minus 3.4. You just have to get your, it's a little bit tougher here because you're working with these negative signs. So just, you have to insert your negative signs properly. And in fact, which is what I did not do. So I was so used to not working with a negative D. This is negative times negative 0.3. Okay. So you have 11 minus 0.3n plus 0.3, which gives you 11 plus 0.3 is 11.3 minus 0.3n. Okay, so now let's plug in minus 3.4 for a sub n and just solve for n, right? Because this minus 3.4 is the last term in the sequence. We're starting at 11, right? We start at 11 and we're going to minus 3.4. So if we just plug this in, if we have our sequence formula correct, we just plug this minus 3.4 in, we can see what n that represents. Okay, minus 0.3 n. So let's bring the 0.3 n to the left. And then we've got 11.3 plus 3.4. Okay, so 14, then 0.7. Okay, so n is, and we can just do this, it would be the same thing if we just said 147 divided by 3. So $49 terms. Okay, 2 terms in an arithmetic sequence are given. Find the indicated term. Okay, so we want to find B214, but we were given these 2 terms that we're not given B sub 1. Okay, so let's try this. So again, we know our formula for an arithmetic sequence is A sub 1 plus, and we can simplify this Okay, so let's say, well, okay, but it's not. We're dealing with it. They're giving us b here. Okay, so b, so 32 is equal to b sub 1 plus n minus 1 times d, and this is equal to minus 303. Okay, so let's just erase this. And then for B54, we've got, well, actually, okay, I'll take it back. We can substitute the n for 32 for the n, right? So we could say 32 minus 1, because it's B32, times d is equal to minus 303. You see, so now b of 54 is equal to b sub 1 plus 54 minus 1 times d is equal to minus 567. So now what we have is two equations and two unknowns. We can solve for our b1 and d now. So we've got, what do we have? We've got b1 plus 31d is equal to minus 303, and then we've got b1 plus 53d is equal to minus 567. So now let's subtract these two equations to get rid of the b1. So 31 minus 53 is minus 22d. Okay, and then minus 303, and then so now it's going to be plus 567. So this is really, if you say 567 minus 303 is what is going to be this value, because it's going to be positive. So this is 4, this is 6, so 264. So this means our d is going to be negative, which does make sense because when we go from n is equal to 32 to 54, we're getting more negative. So d is equal to 264 divided by minus 22. So 264, let's just do the division here. So 1, so 12, so it's minus 12. D is equal to minus 12. Okay, now we can just plug in d is equal to minus 12 into this first equation. So b1 plus 31 times minus 12. Okay. Minus 372 is minus 303. So b1 is equal to minus 303 plus 372. So 372 so 9, 6. So this is b1 is equal to 69. So, okay, so our b sub n is equal to 69 plus n minus 1 times minus 12 minus 12n. So b sub n is equal to 81 minus 12n. Okay? So now we just need to plug in 214. So b 214 is equal to 81 minus 12 times 214. Okay, so 81 minus, okay, so 2568, 81, okay. So so 214 is equal to, so this is going to be negative though, minus 2487. Okay, find the sum. Okay, you could put this into your calculator, or you could actually just do this manually, but they want you to practice the idea of identifying an arithmetic sequence and then using the finite sum formula. I mean, because if it's a lot bigger, let's say you had 1,000 terms, then it'd be hard to find the sum, right? Like using your calculator or whatever, or by hand. So you could use if you have an arithmetic sequence, you could use the partial sum of an arithmetic sequence formula, right? We derived that in a previous video, that formula, but it's given by, so the sum of the first n terms of an arithmetic sequence is n divided by 2 plus, or no, times a sub 1 plus a sub n. Okay, so, but it doesn't tell us that this is an arithmetic sequence yet, but I'm assuming it is. So you go from 4 to 7, that's adding 3, 7 to 10, that's adding 3, 10 to 13, that's adding 3, 13 to 16, that's adding 3. Okay, so, well, we can count the number of terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to be doing this for 12 terms. Okay, we know that a sub 1, the first term, is equal to 4. Okay, do we know that a sub 12? Yeah, we do. The 12th term is 37. So we can just plug this in right into our formula. So s of 12 is equal to 12 divided by 2, then a sub 1 is 4, a sub 12 is 37. So we've got 6 times 37 plus 4 is 41. So 41 times 6 is 246. Okay, so find the sum of the first 40 terms of this sequence. So they don't tell us it's arithmetic, but let's see. Going from 1 to 6, you add 5. 6 to 11, you add 5. 11 to 16, you add 5. Okay, so this is going to be an arithmetic sequence, and we know that the D is equal to 5. Write down everything you know. When you're doing a problem, trying to solve a problem, write down everything that you know for sure. We know for sure that this is an arithmetic sequence, right? So, okay, we know that the D is equal to 5. We know that the A1 is equal to 1. Okay, we're trying to solve for the sum of the first 40 terms. Okay, so we're going from n, we're assuming we're starting at 1. n is equal to 1 to 40. You don't have to start at 1, but like a lot of the formulas in these textbooks are derived based on the sequence starting at 1. But we talked about that in a previous video where you can easily derive formulas for any starting index. Okay. So the sum of the first 40 terms. So we're going to want to use that arithmetic sum formula, which is okay. So we're going to want to sum the first 40 terms. So we're going to have n is equal to, in this formula, we're going to have n is equal to 40. So S of 40 is equal to 40 divided by 2. A sub 1 is equal to 1. And now we just need this A sub 40, right? That's what we're missing. How can we get A sub 40? Well, let's write out let's do what we're doing in previous problems. Let's write the formula for an arithmetic sequence. So A sub n is equal to A sub 1 plus n minus 1 times d. Because we did this like we did this in previous problems where we said where it acts as find the 40th term of the arithmetic sequence. So we've already done this. So we're just doing this again, right? So A sub 1 is 1 plus n minus 1 times 5. 1 plus 5n minus 5. So the A sub n is 5n minus 4. Right, so n is equal to 1, you get 5 minus 4 is 1. N is equal to 2, you get 10 minus 4, you get 6. N is equal to 3, you get 15 minus 4, 11. So that's right. Okay, so now okay, what is that's the formula for this sequence here. So what is A sub 40? It's 5 times 40 minus 4, right? So 5 times 40 is 200. This would be 196. That's A sub 40. So let's plug this into our formula for the sum times 197. So 197 times 20, you get 0, 0, 0, and then add a 0. 18, 19, 0. Okay, so that's the sum of the first 40 terms of the sequence. Okay, find the sum. So similar to the last problem, but it's a little trickier because we got these minus signs. So when we go from minus 7 to minus 11, what are we doing? We're subtracting 4, right? Minus 7 minus 4 is minus 11. So minus 11 to minus 15, we're subtracting 4. So this is going to be an arithmetic sequence with D is equal to minus 4 and A sub 1 is equal to minus 7. Okay? So to do our sum, okay, so this is just like the previous problem. We need to find this A sub, the last term, right? We know we're going from 1, but what is this? Or no, it's not. Okay, no, wait a minute. We know A sub n. Yeah, we need to find that. We know in this situation, this is a little different from the last problem. We know A sub n is minus 39. We just don't know what term this is. So A sub n is equal to A sub 1, so minus 7 plus n minus 1 times minus 4. Get your signs right. Distribute the signs correctly. So minus 4n plus 4. So minus 4n minus 3. That is a sub n. Okay, so what if for this, that this represents this sequence here. So when a sub n is minus 39, what is n? Right, so bring the 4n to the left, and then you've got minus 3 plus 39, which is positive 36. So n is equal to 8. Minus 39 is the 8th term. Or no, the 9th term. Okay, so now we have everything we need. We know that S, the sum of the first 9 terms, that's what this is 9 divided by 2. We know a sub 1 is minus 7. You need to get your signs right. Plus a sub n, so plus negative 39. Okay, so this is minus 46. So 46 divided by 2 is, so minus 23. And then so this is minus 207. That is your sum. Okay, an object in free fall is dropped from a tall cliff. It falls 16 feet in the first second, 48 feet in the second second, and 80 feet in the third second, and so on. Write a formula for the nth term of the arithmetic sequence that represents the distance dn that the object will fall in the nth second. Okay, so let's make a table here. So this would be seconds, and this would be the distance. So after the first second, it's fallen 16 feet. In the second, it falls 16 feet in the first second, 48 feet in the second second. So not total. This is like it's saying in the first second it falls 16 feet and it's accelerating, right? So it just from 0 seconds to 1 second, it falls 16 feet. And then from 1 second to 2 seconds, it falls 48 feet. And then from 2 seconds to 3 seconds, it falls 80 feet. I believe that's what it's saying. In the third second. It hasn't fallen after, it's not saying after 3 seconds it's fallen 80 feet. It's saying in the third second, it falls 80 feet. So now it's asking, write a formula for the nth term of the arithmetic sequence that represents the distance dn that the object will fall in the nth second. In the nth second, so it's like it's saying it's accelerating. So for each successive second, it's going to fall more. So they're saying this is going to be an arithmetic sequence. So 16 to 48. 48 minus 16 is, so this adds 32. So this you should add another 32. 48, 58, 68, 78. Yeah. So you do add 32 there. So okay, but this is not a sub n. They want us to put it in terms of d sub n. Okay, so a sub 1 is 16 plus n minus 1 times the common difference is 32. So so our d sub n is equal to 32n minus 16. Okay, so now it's asking us in the 8th second, how far will the object fall in that 8th second? So assuming this pattern holds all the way to 8 seconds, which I don't think it would, at some point it's because you reach terminal velocity, right? So at some point, this is just practice for arithmetic sequences. But okay, so in the 8th second, what they're asking is, what is d sub 8? So 32. Okay, so 32 times 8 for 256. So 240 feet. What is the total distance the object will fall in 8 seconds? The total distance. So the sum, right? It falls 16 feet in the first second, 48 feet in the second second. So in the first 2 seconds, it falls 16 plus 48 feet. So if we want the total distance the object will fall in in 8 seconds, we just need the sum of the first 8 terms of the arithmetic sequence. We need s of 8. So this would be 8 divided by 2, and then a sub 1 is 16 plus a sub 8, and what we just saw for a sub 8, we just, or d sub 8, s sub 8 is 8 over 2, 16 plus d sub 8, we just saw for d sub 8, right? So 256 times 4 1,024 feet total. Okay, last problem. Compute the sum of the first 50 positive integers that are exactly divisible by 5. The first 50 positive integers. Okay, so 0 is not positive, so this sequence is starting at 5. Okay, and now for integers that are exactly divisible by 5, we're just going to keep adding 5 each time, right? Okay, so this is, we're adding 5 each time. This is an arithmetic sequence with d is equal to positive 5. Okay, a1 is equal to 5. All right, and then we're computing the sum. So in our s sub n formula, we're the first 50 terms. So n is going to be 50, right? So s of 50 is equal to 50 divided by 2, and then a sub 1 is 5 plus, and now we just need a sub 50. We don't have that yet. How do we get a sub 50? Let's use the, let's get the a sub n formula. So is a sub 1 plus n minus 1 times 5. Okay, a sub n is 5n. That makes sense. N is equal to 1, 5, n is equal to 2, 10. You're just multiplying by, right, it's just 5 times the term number. So what is a sub 50? Just plug it in here. 5 times 50. 250. So 50 divided by 2 is 25. 5 plus a sub 50. So 25 times 255. So this is 63, and that is your sum.